doctors, where concepts made crystal clear. Sorry guys, I was not able to upload new videos because of my serious accident, but with your blessings I am now well. So let's continue our journey with respiratory system. In this video, we are going to focus on peripheral chemoreceptors. In last video, we have gone through the central chemoreceptors. If you have not seen that video, first watch that video and continue your journey with this video. So, in peripheral chemoreceptors, heart acts an important role. So, let's see the anatomy of heart. Here we have left atrium, left ventricle, brachiocephalic artery, which divides into left subclavian artery, right subclavian artery. This is our aorta. This is left common carotid artery, right common carotid artery, left internal carotid artery, left external carotid artery, right internal carotid artery, right external carotid artery. And we have also these two cute buddies which plays the significant role in this peripheral chemoreceptor. They are nothing but the aortic bodies, as it is near the aorta, and this is our carotid body as it is near the carotid artery. So how they get stimulated? They will get stimulated by changes in the concentration of carbon dioxide, partial pressure of oxygen and the pH. More specifically speaking, they get stimulated when there is changes in the partial pressure of oxygen, and specifically when the partial pressure of oxygen goes less than 60 mm of Hg. They can get also stimulated by changes in the pH, but here pH doesn't change due to the changes in the concentration of carbon dioxide, but it changes due to metabolic acids. Now let us take some example of metabolic acid. The first example of metabolic acid is lactic acid, which is generated when we are doing some muscular activity. The second important example in the metabolic acid is ketone bodies, which are generated by our kidneys. And as we all know that these are generated when our kidney is suffering from diabetic ketoacidosis. So these metabolic acids as well as the partial pressure of carbon dioxide will increase the H plus ion concentration and it will decrease the pH. Now what happens here? Let us zoom this aortic body. This aortic body consists of two types of cell. This is type 2 cell and this is our type 1 cell. This type 1 cell are known as glomus cells. Inside this type 1 cell we have cute vesicles and it consists of dopamine. In this video we will see how dopamine will help us to increase or decrease the ventilation. Here inside this type 1 cell, along with these dopamine vesicles, we have potassium ions which are positively charged. This is our potassium channel through which potassium moves out of the cell. What happens here? The metabolic acids will increase the H plus ion inside the cell. Along with these metabolic acids, the carbon dioxide will move inside and it will combine with H2O. This H2O and CO2 will combine to form H2CO3. And we know that this compound is unstable, so it will form H plus HCO3 minus. This H plus will also increases the electropositivity inside the cell. Now, as you can see that this inside the cell the positivity increases. It will cause opening of an important channel, and that is calcium channel. Due to the increase in the H plus ion inside the cell, the potassium channel will get closed off. Due to the closure of the potassium channel, potassium plus hydrogen both are electropositive, they will increase electropositivity and they will cause opening of the calcium channels. Now, as soon as when the calcium come inside the cell, it will take these dopamine vesicles towards the periphery of the cell and it will cause opening of these vesicles. Opening of these vesicles causes release of dopamine. Now an important step comes here. When the aortic body stimulate the nerve endings, it will move to cranial nerve number 10. And when this carotid body will get stimulated, it will move towards the cranial nerve number 9. And we know that the cranial nerve number 10 is vagus nerve and cranial nerve number 9 is glossopharyngeal nerve. Now what happens here? The cranial nerve number 10 and cranial nerve number 9 will move to dorsal respiratory group of neurons. This DRG gets activated and it will stimulate VRG, that is ventral respiratory group of neurons. Both of these neurons will stimulate the muscles outside the lungs, that is diaphragm and external intercostal muscles. What it will cause? It will increases the activity of both of these muscles by phrenic nerve and by activating T1 to T11 nerves. Now what happens? More and more oxygen will come inside the alveoli and it will be transferred to the capillaries. So here the concentration of oxygen increases. In reverse, what happens from the capillaries to the alveoli? More and more amount of carbon dioxide will be transferred to the alveoli and it will be moved out of the body. So there will be increase in the respiratory rate as well as respiratory depth. What happens here? More and more amount of carbon dioxide moves out and more amount of pure oxygen comes in. But as I have said you that they are stimulated by metabolic acids, that is ketone bodies and lactic acids, they will not be moved out through this accelerated respiration. So our kidney plays an important role here. There is a mechanism inside the kidney which will compensate and which will take these ketone bodies out of the body, which we will understand in detail when we are talking about kidney system. So in this manner, these peripheral chemoreceptors get activated and will stimulate cranial nerve number 9 and cranial nerve number 10. These cranial nerves will activate DRG, VRG and ultimately increases the respiratory process, through which the carbon dioxide is washed out and more amount of oxygen comes in. And this will occur until when the demand of oxygen inside the cell reaches its maximum. So before ending this video, I want to underline certain more receptors which are present in the respiratory system, and they are also plays an important role in the neural mechanism of breathing or nervous regulation of breathing. So first receptor about which I want to talk here are stretch receptors. Where they are present? They are present in the smooth muscles of bronchioles or bronchi also, and at the certain locations in the visceral pleura. Now what is the mechanism? How they get activated? Let's understand that. In certain conditions wherein what you do, you goes on inspiring more and more amount of oxygenated air. When you inspire more than the capacity, what happens? these stretch receptors gets activated. These stretch receptors are connected with the cranial nerve number 10. What cranial nerve number 10 will do? It will directly go to apneustic center as well as pneumotaxic center. They will combinedly activate our DRG. Our DRG will activate VRG. VRG, inside VRG, we know that it consists of inspiratory neurons as well as the expiratory neurons. So what happens in this case? As soon as the DRG will stimulate the VRG, here the inspiratory impulses are stopped and the expiratory impulses will get started. So inspiration is stopped here and expiration will be started. So this is how the stretch receptors works. Another important receptor which is present inside our bronchioles or bronchi are the irritant receptors. The name itself suggests that they will get stimulated when some irritant comes in. Let's suppose some allergens like dust, pollen or anything to which your respiratory system is allergic. What happens when certain allergen comes inside your bronchi or in contact with these irritant receptors? They will also directly connected to the cranial nerve number 10. What happens? This cranial nerve number 10 moves inside the brain and they will activate certain reflexes of our body, which are known as the protective reflexes of our body. Number 1 is sneeze reflex. And number 2 is cough reflex. What happens when the irritant comes in the respiratory system? They will be sneezed out, or they will, if they will go inside the trachea, and what happens? They will stimulate the irritant receptor, and there gets coughed out. Before moving in certain other types of receptors, I want to underline something here. This whole mechanism wherein the inspiration gets stopped and the expirations get started, this reflex is known as Herring-Brewer reflex. So I want to just add the name of this reflex, so I repeated the thing. Another is irritant receptors. The third receptor which are present inside are JC receptors. Now what do I mean by JC receptors? They are nothing but juxtacapillary receptors. They are present somewhere here. Now when they get activated, they will get activated when we are suffering from a certain type of disease like pneumonia or pulmonary edema. What happens in here? The respiratory membrane gets thickened due to the accumulation of fluid. And we have studied this concept in our previous videos also, that when the respiratory membrane gets thickened, the exchange of gases gets difficult. So these juxtacapillary receptors gets activated and it will start rapid but shallow breathing. It is rapid plus shallow breathing. And what this is known as? This is nothing but dyspnea, which is an important sign in pulmonary edema. The next receptor about which I want to talk here is present in our brain, and that is inside the hypothalamus. Here our hypothalamus is present. We know that hypothalamus is concerned with the maintenance of the body temperature, right? So let's take an example wherein someone pushes you inside a valley which is full of cold water, or you jump inside the cold water. What is the first reflex which we will do? That is right, that is deep inspiration. So here I want to underline that hypothalamus will also play a role in the process of breathing. Another thing which is present inside the brain is limbic system, and we all know that this limbic system is concerned with our emotions. Like might be you have seen two children from one child, the other child will take his favorite toy. What happens? what he will or she will do? He or she gets angry, right? And the process of breathing changes, right? So limbic system also plays a role in the neural control of breathing. Last but not the least, last one is the proprioceptor, which are present inside the muscle, right? And proprioceptor, name itself suggests it concerned with the changes in the movement, right? So when you are doing some muscular activity, this proprioceptor will get activated. They will move through the ascending pathway of our central nervous system, and it will cause changes in the DRG and then VRG, and it will increase the respiratory rate and respiratory depth. So guys, in this video, I know that this video was quite long. We discussed about the peripheral chemoreceptors, and along with that we also focused on certain small receptors, but they are very important. As you have seen, we focused on stretch receptor, we focused on irritant receptor, extracapillary receptor, hypothalamus, limbic system, and lastly we focused on proprioceptors and how they are connected to cranial nerve number 10 and will increase or decrease the respiratory rate and respiratory depth, and they are playing an important role in the neural control of breathing. Hope you got your concept clear. If not, watch it repeatedly, read from your books, and your concept will get crystal clear. Until then, enjoy learning. Bye bye.